a lot of links throughout that you're welcome to click around in. So hi, everybody. Thanks so much, Ed, for the invitation. I'm Julie Lowndes, and as Ed said, I'm a marine ecologist, and I actually knew about JPL back in my PhD days when I was studying squid and squid migration in the California current. And so I think of a different type of jet propulsion in terms of squid, but it's been really neat as I have gotten more into informatics and open science to connect with Ed and to have this invitation to join the JPL seminar series today. And I'm so excited to be here with Celia who has been working with us through the NASA Openscapes project for many years now. PO.DAAC and the many people involved from PO.DAAC, including Catalina, Cassie, Nikki, Victoria, Jack, have just been phenomenal contributions to teaching cloud and open science and really helping change the way people use data on the cloud and do science for really important applications. So just really excited to be here. And I'll speak for a little bit, and Celia will share some examples as well, and then I'll wrap things up. So that's kind of our plan for today, and we'll have time for discussion. So we're going to be talking today about how the NASA Openscapes community supports Earthdata users migrating their workflows to the cloud. And really the motivation for the work that we do with Openscapes is really, what if we connected our skills and our values around climate, around social justice, as our daily practice in our workflows? So how can we think about how we can use technology and data science, open science with leadership skills and people so that we can tackle these big challenges together? So we're really motivated around learning from different communities and bringing what works from different places as we grow and build together. So Openscapes as a open source community is an approach. It's a community that is helping shift culture by helping people move from lonely science towards teamwork as we explore and navigate the open science landscape safely with our teams. So we really think about open science as a whole landscape of data and tools and people that with pathways that exist already, some emergent pathways. And we know that in daily life, people can feel pretty lonely and disconnected, like the animals kind of in the bottom left corner of this illustration. So we're really focused on helping bring people together to help find each other, see the landscape, and start on a safe pathway forward, and then become, help each other, become mentors to each other, build new paths as needed. So we really think about this approach both in terms of helping scientists get into open science and also cloud. And so I'd say too, the Openscapes project, we work with NASA. We also work with other government agencies like NOAA Fisheries and the EPA. We've worked with academic groups and also the Fred Hutch Cancer Center. So we're working with a lot of different groups that may or may not be focused on cloud. But what we'll focus on first is NASA Openscapes. So this is a project that's in its 4th year now, supporting open NASA Earth Science in the cloud. And what the goals of this community is to create a mentor community across the NASA Earth Science data centers that are focused on supporting users. So here we are in our 12th year, in our 4th year, and we have 12 of the 12 different data centers engaging in NASA Openscapes and really learning from each other and creating new approaches to supporting users together. So the main goals of this community have been to co-create common tutorials and to test them early and often through hosting cloud training events and then practicing open science and using the same tools that we're teaching daily within our orgs. So we've heard the term proving ground for open source, and thinking that this has been a community that's been really a proving ground for how we can incorporate open source community work into our daily jobs, which I thought was kind of neat. So the way we work is really through consistently investing in building trust with each other, getting feedback from each other, iterating, and then shaping tools and approaches to support users. So this is a figure from an AGU poster that the mentors led a few years ago now, where it shows that we start off at the top as this pretty small NASA Openscapes mentor community where we learn together first and then start to peer teach back at the different data centers and across other colleagues that we work with in order to document what we're learning and onboard new folks to the practices that we're testing. And then pretty early on, we began in the yellow to teach scientists and end users. And so we do this through a variety of different ways, through hackathons, through in-person workshops and webinars, and also through the Openscapes Champions Program, which is a format where we work more deeply with scientists over 2 months, and so are able to test and we'll test things. And I'll mention the Champions Program a couple times today. And then part of this work as well is to then connect with the broader open source community and collaborate and give back. So I mentioned other government agencies that we work with. We also work with software engineers who work in open source at RStudio, at Jupyter, Pangeo, and GitHub. And so thinking about how to bring best practices into this work and connect. And so what this looks like, we're a remote community, but it looks like having sometimes synchronous calls that are regular where people can show up and learn together, test, troubleshoot together. This is a screenshot from one of our regular calls where someone was screen sharing and testing code, and then Catalina says, "It works for me." Amy Steicher, who's at NSIDC, says it works for me too. And then Rupesh from ORNL says that this works for him as well. So this is really neat across the data centers to be testing these tools that work across these data centers. And I'll say too, Celia and I were just in a co-working session just in the hour previous to this call, where she is bringing her engineering skills and experiences using wget and curl for accessing data locally and helping improve the approaches that LP.DAAC and NSIDC were also thinking about. So I think it's a really neat, it was a really cool experience just now. And I wish I had a screenshot from that, but that was a really neat moment just a few minutes ago. What Open can also look like is asynchronous contributions. So we have workflows where we use GitHub. We're able to create, we have a common place called our Earthdata Cloud Cookbook where we're writing our tutorials. And this is an email that I get into my inbox where I see that Alexis Hunsinger from JESDIS has updated a few things with the glossary to the cookbook. And so I'm able to, in my email, see what's going on. And then if she has tagged somebody for review, we're able to take care of that asynchronously and get her work into the cookbook really quickly so that we can all benefit from it. Another thing that this looks like is project management in the same place as code and documentation. So we're using GitHub issues for all of our open project management. And it's great because, like that example just previous with Alexis, when she's updating code and documentation, that's also linked here with our shared to-do and calendar. So we're becoming, we're trying to, openly track our progress and to-dos, and then also that welcomes other folks to join, whether or not you've been interacting with the NASA Openscapes community previously. And then one other way this looks like is thinking about effective teams and how we can redefine teams in all kinds of different ways across the decks and in little huddles to take care of different workshops or needs. So really, we're focused on building empathy, time to reflect and see what is working, and really building psychological safety and growth mindsets within ourselves and the folks that we teach through the workshops. So some of the ways this looks like is having collaborative documentation where people can share ideas, even if there's not enough time for everyone to unmute, and also to use GitHub issues in the way I was just describing. So really, this approach with Openscapes and beyond is thinking about how technical and social infrastructure go together and how when you use the same types of tooling, you're able to build these teams and be so effective and grow this community. And then also when you have those sort of similar mindsets with across people and teams, then you're able to iterate and incorporate new tooling. And that this is this sort of beautiful feedback loop that grows as the software scape grows and as teams grow. So that's a big part of our approach, is that these tooling and people are always interoperating. So I'll share a few stories now from NASA Openscapes, and then Celia will share a few more from PO.DAAC. The first is about Earth Access. Earth Access is a Python library that is really, it aims to be the technical and social bridge between the NASA Earthdata tool stack, which are described, illustrated on the left here, and the open source scientific research community. So Earth Access can be a first entry point to folks when they are interacting with data from NASA Earthdata and trying to work with that either on the cloud or locally. This started with, this was first created by Luis Lopez from NSIDC, when through working with some of these champions science teams, seeing kind of the first steps in working in the cloud involved 30 lines of terminal code in some cases, and trying to figure out authentication. And there was a lot of first steps before folks were able to use the data. And this has turned that experience that maybe a few dozen scientists had in the early days to about 2 lines of Python code that are now used by tens of thousands of people, which has been really exciting. So this is a screenshot of some of the Earth Access code. So that it's a Python library that you can install. It takes care of authentication with Earthdata login. It searches using the CMR API, and then it lets you download or work in the cloud with the same lines of code. So this has been a more sort of friendly approach for meeting researchers where they are, who may or may not be experienced with coding at all. And something that's really neat is that we also have complements to Earth Access in R and in MATLAB, because we've been working with a lot of users who use those languages as well. There's a lot going on with Earth Access now. It is switched from being something that Luis Lopez designed and developed to a whole open source community across multiple data centers at NASA and with the broader open science community, which is really awesome. I highly recommend a recent ESDS Tech Spotlight on Earth Access, and there's a link here where there's slides, notebooks, live demo, and also a summary blog. But some of the things that Luis and colleagues are working on now is how to operate with the data in the background to save both time, processing time, and egress costs. And so there's some statistics here showing that with Earth Access, the time and the sizes diminish remarkably. Another story from the NASA Openscapes community is about DAACifying code and helping go from serial code to parallel code in order to leverage the true power of the cloud, right? Moving the code that you have right now to the cloud is not the end goal here. It's really to be able to run your code in parallel rather than serial, like this diagram shows, so that you can do things in less time. So the story around parallelization really starts with PO.DAAC, which is really awesome. The tutorials developed in-house at PO.DAAC were the first that were within the NASA Openscapes community around parallelizing code. And we worked through some of those tutorials in one of the mentors co-working when Masajami from LP.DAAC had a JEDI notebook that was causing issues around parallelization. And so Luis Lopez was able to screen share, or Masa screen shared, and Luis helped rework her code using Earth access so that it could be optimized for parallelization. And then, and with the rest of us watching and learning from that experience. And then from there, Masa created a whole lesson that she's taught last week in the champions cohort that's going on right now. So now we're able to help scientists see where they're struggling and how we can help them have real powerful experiences in the cloud. And something that's also builds from that is that we do have some early examples of scientists using parallelized code in the cloud and really feeling that power of the cloud. So Aaron Morelli is a scientist at the University of Washington, and he was in a champions cohort last year in 2013. And he recently shared his story with the current group of science champions teams, where he said that parallelizing his code really felt like a superpower. He was able to process much more code than he had before, and that actually it's not that he was just taking the things that he was doing before and doing them faster. It was that he was thinking differently about what was possible because he was able to subset and explore and do analyses so much more powerfully. So I think that's an amazing story in itself. And then in addition to that, Aaron has also fledged, we are saying it, from our experimental learning Jupyter Hub cloud environment. And he's been able to use a service called Coiled that has helped him parallelize his code and learn how to use this tool called PO.DAAC. But then he was able to attach his own credit card for the university. So he's able to pay for his own science through the university and really has this this story about learning in our shared Jupyter Hub environment and then going off to do this himself. So this is huge, and we're looking to support many more users and help tell those stories and help make it easier for other folks to follow in those steps. So we've got a lot of ongoing work across NASA Openscapes. Those were just a few examples. We have a lot of goals around improving our cloud infrastructure and making it easier for folks to take their compute environments to different places as part of fledging. We're working on the cloud cookbook and continually updating the resources there. The Earth Access Python library I mentioned and R and MATLAB libraries. And also thinking about how to automate workshop planning, because we are leading a lot of teaching events and thinking about all the labor and work that goes into engaging participants, getting them into the hub, making sure that they've got the help that they need. So we're working on that as well. And now I'll advance and let Celia share as well.
Thank you, Julie, for going over all of that. Now I'm going to zoom in on the PO.DAAC experience within Openscapes. So over the past 3 years, we had several team members participate in Openscapes. It really began with Catalina and Jack, and then now we have Cassie, me, Nikki, and Victoria participating. And the reason why we participate is to, in this orange box, to really engage in the cloud and open science mindset with everyone at Openscapes. It provides a DAAC mentor training, so trains us to be better mentors at the DAACs here, and we really build a community between all the DAACs and with our users as well. And Openscapes has been just this workhorse in providing user training for all the users of the NASA Earthdata. Here we list overall on the right-hand side these goals that we have with Openscapes to ease the burden on Earthdata end users by consolidating resources. An example is how we've consolidated tutorials and resources to the NASA Earthdata Cloud Cookbook made collaboratively by the Openscapes mentors. And we want to make all our tutorials and guides consistent to view for users. And this decreases the duplication of work, because whereas we could have different tutorials, but for all the same things, and located at all the different DAACs. Now we have a centralized tutorial at the Cloud Cookbook. Another example of decreased duplication of work is, of course, the Earth Access package. So many of the DAACs are now incorporating Earth Access into tutorials and telling everyone you can use this to make things easier for yourself. And yeah, our goal is really to collaborate towards supporting interdisciplinary NASA data use, since if users see the same things coming from different DAACs, or see Openscapes resources coming from all the different DAACs, they're already acquainted with it, and now they can feel it's easier to jump between using different DAACs data and be interdisciplinary. And the last point is that the 2I2C Cloud Hub provided by Openscapes is so key for prototyping our work and onboarding early adopters. And we've been relying on it so much for training and workshops. Next. So the first big point is that with the Openscapes Cloud Cookbook that was developed a few years ago, Cassie became like a star contributor to the Openscapes Cookbook. She became a chef, so that's why she was able to so quickly stand up our own PO.DAAC cookbook. And so our PO.DAAC cookbook is modeled after the Openscapes cookbook. And there are several resources in it that are actually links to the original Openscapes cookbook. And so here we see another, reusing material, reusing centralized resources. And the second is that in this cookbook, we've also adopted Earth Access so easily in the tutorials, and workflows are all updated with Earth Access when we show them in the cookbook. The 2023 summer intern at PO.DAAC, she easily learned Earth Access and just switched it into all of our tutorials. And the next thing is that we have regularly engaged with the Openscapes champions cohorts and helped to train them each year. Yeah, next. And so with not just the Openscapes champions cohorts, but PO.DAAC has also interacted with users with the help of Openscapes by hosting several workshops over the years that relied on the 2I2C Cloud Hub. We've listed the 2021 Cloud Hackathon, the same year AGU Cloud Workshop, followed by I think our very first SWOT workshop. It was the 2022 SWOT Ocean workshop. That was a learning experience to bring the users into using the 2I2C Hub to test things out. Next was the 2023 AGU Cloud Workshop, and most recently the 2024 AGU Chapman workshop was SWOT focused. And that one was spearheaded by Cassie and Catalina. And on the right-hand side, you see all the feedback, or not all, showing off the feedback they got from that successful workshop. Participants noted how easy it was to do things, and it really made them eager to try things out. There were also comments about PO.DAAC documentation being invaluable for further data exploration, and that they think the cookbook will be a great resource for teaching concepts to students. So they find it easy and they don't have to make their own materials to pass on to other people. They're just going to use ours, which is great. Yeah, so this really emphasizes how the leveraging the 2I2C Hub has been so important to us. is so useful for developing and prototyping our own work and training ourselves, then it just translates into training other people easily. My third point is that we the 2I2C hub really its usefulness really speaks to this need overall across the DAACs for a cloud playground. And I'm sure you've heard that Cassie and others really pushed for the cloud playground to happen. Unfortunately, it hasn't, but I just want to note that so much discussion about the cloud playground and what our needs from it are, and so much discussion happened in the Openscapes community in a subgroup of it. So I think it was really useful for fostering this kind of discussion for things that we need. Last point, only because it is the most recent that I've heard of, is that we haven't just adopted Earth access tutorials at PO.DAAC, but like I want to come full circle and shout out to Ayush, who identified, issues that PO.DAAC users have or potentially will have with PO.DAAC data using it in the cloud. And to tackle those issues, Ayush actually found Earth Access, connected with the Earth Access developers himself. And through that, he got into attending the Openscapes biweekly hack meetings. And so it's kind of coming full circle that we've got Ayush through his work at PO.DAAC is working on contributing back to Earth access. So I think that's really great. It's like a star example of connections with Openscapes. I think this is my last one. Here, I think I'm kind of speaking in general, speaking on behalf of all the other PO.DAAC participants in Openscapes, that individually, we really value this opportunity to learn from each other across the DAACs. Everyone has different skills, and it is so great to troubleshoot with each other. And, with doing dry runs and co-hosting workshops together, it really brings up our workshop skills. And we're not just, it goes both ways. So which leads me to the right-hand side table of the current year's NASA champions teams. These teams are made up of our end users, and we have 9 teams in total this year. 6 of those teams have expressed that their data usage is multi-DAAC. So they have interdisciplinary interests and interested in more than one DAAC's data. 6 out of the 9. And of the 9, 3 list interests with PO.DAAC data. The community also has interest back into us at PO.DAAC. Yeah. So then back to listing individual what we value. What we found individually in Openscapes, gaining GitHub skills for code and project management. And for me personally, I really like the motivation and encouragement at all the Openscapes meetings. And week after week, I'm just reminded that we all encounter the same questions. And that is just really helpful to our approach in how to answer user questions and how to train ourselves. I also credit Openscapes a lot with making me better at answering user questions and better at just engaging with the user community. Because this point is in exercising engagement with empathy. It's now something I try to just live by all the time. Like, what is the user looking to get out of this? And as I am explaining something, being aware of points like, is this jargon? Is this too convoluted? Does this actually help them? And so all these things, from workshop skills to exercising engagement to empathy. It's always a work in progress, and it's the Openscapes community that keeps me going. Besides that, Openscapes now, with so many mentors from across the DAACs, it has a great community presence at AGU and ESIP and other meetings like that. So I've been to AGU and ESIP a couple times, and we've had in-person meetups with whoever also happens to be there, and just jump right into, either socializing or, troubleshooting spontaneously. It's great. And last point is Openscapes also offers formal training into this kind of mentorship and um, user engagement, which is through the Carpentries program. If you're familiar with either software carpentry or data carpentries, they're together, they're called the Carpentries. And so Openscapes has offered us Carpentries training attendance. Yeah. So I think back to Julie.
Great. Thank you so much, Celia. It's so, yeah, it's amazing to hear your personal connections, as well as all of the work that you do and do with your team and the others at PO.DAAC. I think that's like a great segue to really thinking about how we shift culture to open science. And so I'll share a little bit more big picture and then a few more examples. But I think, many people in the open source community, me included, learned through really great mentors and felt empowered and saw different ways of working. And so growing this community and building the number of people that do this and mentor with empathy is really, really, really super. So thank you for sharing that. So we think about shifting culture to open science is really about changes in how individuals operate, both with technical skills and that shift in mindsets and empathy, like you said, Celia. And then also thinking about how teams operate around psychological safety and even thinking that you're part of a team, and changing workflows so that they are a bit more easy, more automated or less cumbersome for individuals. And then also thinking about how different organizations can operate differently. So I think NASA Earthdata is such an amazing example across the DAACs. We've also been working with NOAA Fisheries and their open science vision and open science leadership is really phenomenal. And then also state agencies like the California Water Boards, who I know have connections to PO.DAAC as well. They've been sort of internally forking Openscapes and doing this on their own as part of their additional programming within the water boards. And then also thinking about how we can learn across government, across communities in this open science world. So one of the high-level ways that we work that kind of grounds everything we do is we call it our Openscapes flywheel. This is developed with Aaron Robinson of Metadata Game Changers, who has co-led the NASA Openscapes work since the very ideation and throughout. And the flywheel is based on a concept by Jim Collins, who sees that small repeated steps over and over let you build momentum like a flywheel, and that when you first try to go around this flywheel or push this big heavy thing, it's a lot of effort, you don't see much movement, but you do it again and again and it's still a lot of work, and then it starts to fly. And I think that's what gives me so much hope and joy, seeing how PO.DAAC and Celia has been building on this open science framework. So we really focus on, I'm going to just briefly start in the bottom left and narrate around the flywheel one time. But really we start on amplifying open leaders and really leveraging what's common, what works, skills and tools that people are already using, and then inspire broader communities to join. And when folks are inspired, then we engage this future us mindset where we're thinking about teams and what's to come down the line. And so we do that by welcoming folks and creating a space and place to connect and collaborate. And then we're empowering a learning culture where we invest in that learning and trust and skill building, and then work openly and role model open. And then the flywheel spins again. So we think about this with every workshop we teach, the champions cohorts. We think about this for meetings we run, and just thinking about how we do open science as a daily practice. When we teach your champions cohorts, we're often focused on teaching growth mindsets, both in terms of concepts and tools that can reimagine workflows. So this figure on the top left is really the figure that changed my life probably more than anything, both in terms of science and work. Because it's the idea that no matter what your data set, no matter what your science question, no matter what your study system, if you're working with data, you'll go through these steps. So you'll import the data into some kind of software that lets you analyze it, and then tidying it is a separate, distinct step. And this can take 80% of a data scientist's time if you tidy data. Well, just the concept of tidying data, but also the idea that you keep that separate from when you're trying to understand your data and trying to do your science. And that's where you're able to transform and visualize and model. But it's that tidying that can take so much time. And for us in the cloud, that's, whether we're downloading, that's how we're subsetting, that's how we're like just assembling the data so that we can ask our questions. So really recognizing that that's a separate step. There's tools for it, and that we can think about science differently if we sort of have that conceptual understanding. So we talk about concepts like that in the Champions program, as well as tools like Quarto and GitHub that Celia mentioned and that we use in the Mentors program as well. We also talk about growth mindsets, and really that mentorship is a skill that we can develop, just like other skills that we learn. And so we really focus on that growth mindset, that empathy, generosity, asking questions, listening. We really try to bring what we learn and see from other groups in the social justice and open science movements to our work. I'll just give a brief a couple examples from NOAA Fisheries from the Champions program before we wrap up, but just so you can see some examples of other folks using PO.DAAC data and thinking about this in their own work at NOAA Fisheries. So this is a quote by Adrián Rios, who says, "As fisheries scientists, we know that when we're in rough seas, it's important to keep the ship afloat and get out of the storm. Openscapes has helped them steer out of the storm of email chains with 37 versions of the same spreadsheet and to the calmer waters of open science and meaning collaboration using tools like R." So Audie's sort of a prime example of someone who learned these concepts and tools for getting away from those 37 versions of the same spreadsheet, and now teaches others at NOAA Fisheries as well as part of this cross-government mentor community. But when we teach the Champions program, we ask that at the end of the 2-month program that we teach, we ask for folks to spend 3 minutes telling us where they started, what they're thinking about, and what their kind of next steps might be, however they want to frame that. So this is an example. It's not about cloud, but this was after 2 months going through the Champions program, how a group of folks who didn't necessarily think they were a team to begin with were able to talk about their data challenges, see that there were CSV files everywhere. People didn't use the same tools. People were underscoring things by saying final, really final, when it was a data analysis, and how they could envision making things better and have these challenges to overcome. And I think what's neat now is we've led, we're right now leading our 23rd cohort of the Champions program. And so we're able to not only see these stories of folks and their progress after 2 months working closely with us, but also over time. So this was a similar team 2 months later after they had finished the program, where they were actually able to leave that kind of planning stage and get into the action stage. And so this group was able to automate their whole data to web products pipeline, where they went from having 90 scientists email data over 6 weeks that somebody had to manage and deal with. they were able to change that to a data uploader that would automate into Google Sheets, then be accessible by R code that had some figures that it would generate and some documentation that it would generate from the data it saw, that then could be passed on to another team that was able to collaborate in Google Drive, because that was the tool that they use, and then ultimately go back to R and publish a web tool. So I think it's really neat to see like what this team was able to do in such a short amount of time following that. And then we're also seeing a few years after the Champions cohort how a similar team has made an R package to streamline a lot of the processes that they went through, so that other people at different science centers at NOAA can use that same R package, and it's documented and easy to use. And they're also using GitHub teams, GitHub projects to organize their weekly learning sessions. So I think, that's a lot of examples in cloud and otherwise, but I think the sort of coming back where we began is thinking about, what's possible because of all of this. And I think we're really motivated by spending more time on science and solutions, and not only saving time, but having better products, less lost day to day and lost during secession. It's about improving morale as we're working together and helping each other get unstuck and being less lonely, and building real relationships. And then it's ultimately about tackling big challenges in front of us in terms of climate and social change. So yeah, these are a few things that recently have been motivating and inspiring us. Recoding America is a really phenomenal book about coding in government, and how we can work together. And then also inspired by storytelling through Taylor Swift and how she's specific and is building a movement of people that identify with that, and what I'm curious what the open science community can do with that kind of role model. But anyway, this has been so great. I really appreciate being here. Thank you so much, Celia, for co-presenting, and for Ed for the invitation, and for all of you here and all of the other mentors that I know are here as well. So thanks so much. Here's some more resources for you too. Thanks.
Well, thank you, Julie and Celia, for this very fantastic presentation on Openscapes. I learned a hell of a lot more of the program than I thought being part of, kind of like on the periphery of